Hello and welcome to Lesson 3, Supply and Demand Equilibrium. In this lesson, we'll be putting together everything we know about supply and demand in order to find our equilibrium point. Our objectives are to understand the relationship between the supply and demand curves, as well as understand how the equilibrium point is reached. We will calculate the equilibrium point graphically and algebraically. Notice that in our graph down here, we can see our equilibrium point is obviously where the two lines intersect. And we're going to examine how we get to the equilibrium point and then try to find it. Okay, in our first example here, I just want to talk about supply and demand given some situations. So here we're looking at the milk market. And on our vertical axes, we're going to go ahead and put price per quart since, as I stated in the previous video, historically, that's where we put it because we're not really saying that there's a causal relationship between price and quantity. So on the y-axis, we have quantity in thousands of quarts. Okay, so if we think about our supply, since we just finished looking at supply curves, we have our initial point right here, and maybe this point right here is only 50 cents or something like that. We don't know. So I'm going to go ahead and put in 50 cents. And what does that mean? This is our starting point. What does that mean? That means that we are willing to supply 0 quarts at 50 cents. So we're not willing to produce, milk our cows, or distribute any of our milk at 50 cents. That's what that means. In order for us to start distributing quantity, the price has to go up a little bit more. It's not worth it to us to sell it for 50 cents. So our demand curve would start here and then it would kind of rise, and I have it rising in a curve. Now let's think about our demand curve. So with our demand curve, at 1,000 gallons, if we were to say charge $7, that's all that somebody would be willing to buy is just one set of the $1,000 because of the 1,000 quarts, because $7 is quite a lot of money. So when the price is high, the demand market is not willing to buy so much quantity. But notice that as we start to drop the price down this pink line here, our demand curve, the quantity increases, meaning that, people are going to start to buy more quantity the lower the price. They get excited and they want more. So we're graphing these two together. Now let's look at scenario A. Let's say for whatever reason, the suppliers think that they're only going to get about $1 per quart for supplying their milk. So I've plotted, here's your dollar right here, and that's about a little over 1,000 quarts of milk. Well, notice that that's what we are supplying. So right here, and I'll go ahead and I'll put the point here. Let's do it in a different color. So for $1, we will only be supplying about, we'll say that's about 13. So we'll just actually keep the same unit. So that's about 1.3 in thousands, of course, quantity. So that's all we're willing to supply for $1. But look what happens. Where's our demand at $1? Well, our demand is way up here. People want to buy almost 7,000 quarts, close to 8 actually. This is 8 here and this is 7. So really about 7,500 quarts. So we have a pretty big discrepancy here between what we're supplying at $1 versus what the public is demanding at $1. So what happens? What happens? Well, in that case, the price starts to go up because more people are demanding more, and that starts to make the price go up. And you can see what happens as the price goes up, the demand and supply curves start to narrow. So let's look at what happens here in B. So after this first incident, suppliers think, wow, we have this huge demand, so we're going to increase the price to $5. Okay, so they think they're going to get $5 now for a quart. So they go ahead, and if we look right here, we've got our $5 here. So what are we supplying here? Okay, well, let's look at that. So if we kind of come down here like this and say, well, at $5, we're willing, not 3 here, we're willing to supply 6,000 quarts. So at $5, and let's just change that here. So at $5, we're willing to supply 6,000 quarts right here, $5. But are people willing to purchase that? Are they demanding that? And that's where this dotted line here on B comes in. In reality, we have another discrepancy, right? At $5, that's a little bit more money than the $1. So our customers, our consumers are saying, no, we only want, and if we come down here and look, we only want 3,000 quarts. So again, we have a discrepancy. So now what happens? Well, in this case now, the price starts to go down. Supply goes down, demand goes down, and you can see what happens here. As our demand increases, when we have low price, as our price increases here versus here, our supply is going down, our price is going down. Eventually, we reach this point right here in the middle. And that point, as you can predict, is called our equilibrium point. And at that point, it's a very special point because that is where the quantity that is supplied is in line with the demand that is out there. And the price aligns with that. So we look at our graph here, that's around 4,000, and it looks like the prices for $3, the quantity demanded and supplied, are in equilibrium at a quantity of 4,000 quarts. That's a little bit how the supply and demand curve work together to create equilibrium. So now let's look at some sample problems. Let's figure out how to solve these. Our first problem is just linear. We want to find the equilibrium price and quantity using linear equations. We're going to do this one by graphing, and then we're going to find our exact answer algebraically. When we graph, remember that it's as simple as just coming up with some points. So let's look at our first equation, the quantity demanded. And the easiest thing is to look for some intercepts maybe. So if we made P be 0, in this case we would have the quantity demanded is equal to 80 minus 4 times 0. 4 times 0 is just 0, so the quantity demanded would be 80. Now notice we have quantity demanded here, so what I should really write instead of x and y is what we're comfortable with. I should write, let's see here, we'll look at the quantity demanded here and the price here. So when I turned my price into 0, the quantity demanded is 80. So I'm just plugging in points. If we were to plot that here on our curve, that would be right here. So for a price of 0, quantity demanded is 80. Now we need another point because we need 2 points to make a line. So I'll go ahead and see maybe about this axis here. What happens if I plug in a 0 for quantity demanded so that I can find my point on the other axis? So 0 here equals 80 minus 4p. Well, we would add 80 to the other side and get 80 equals negative 4p, or I should say we subtract 80 to the other side. And then if we divide by negative 4, we get a price of 20. So when our quantity is 0, we get a price of 20. Let's go ahead and graph that. So that would be up here. From those 2 points, we can now draw and connect our demand curve. And we'll just do that. All right, great. Now for our second equation, let's go ahead and set up a table for that one as well. So in this case, we are also going to have our quantity demanded versus price. Okay, so this is now our supply curve. So remember, we should have a positive sloping curve. Again, let's go ahead and put in a 0 for price. So if we put in a 0 here, the quantity supplied is negative 20. That's going to be a little bit hard to show because that means it's way over here. And remember, we don't work with the other quadrants, so that point isn't going to help us. Let's go ahead and try the other intercept. So let's put a 0 in here for quantity supplied, and then let's check our price. So we have 0 equals negative 20 plus 8p. We would add 20 to the other side. And if we divided both sides by 8, then we could find out that 20 divided by 8 is approximately $2.50. All right, we can use that here. So now we have a point of when the quantity demanded is 0, then we have $2.50 right here for our price. Well, we still need another point. So let's just go ahead and plug in a random quantity somewhere up here of, let's try 90. So if we plug in a quantity of 90, or actually we'll do 90. So let's say 90 equals negative 20 plus 8p. And we were to solve, we'll move some of this out of the way. We would add 20 to this and get 110 equals 8p. And then if we divide both sides by 8, 110 divided by 8 would give us $13.75 for a price. All right, so let's go ahead and plot that point. So remember, we picked, and let's go ahead and write it on here. So instead of our negative 20 and our 0, we picked a quantity of 90, and we got $13.75. So here's 90, and $13.75 is about right here. And now we can connect our graph. And here we go. We just need to go through these 2 points. Okay, so we have graphed our supply and demand functions. The problem is it's very hard to find this equilibrium point because it's not exactly on a crosshair. So we can see that it's somewhere around $47 and, or I should say 47 units, and somewhere around $8.50, but we don't have an exact value. This is where algebra is handy. So we want to find this point where the supply function equals the demand function. So all we have to do is set these equal to each other. So let's go ahead and do that. Let's take negative 20 plus 8p and set that equal to 80 minus 4p. Now we have an algebraic equation that we can just simplify and solve. So we are going to add 4p to both sides, and we're going to add 20 to both sides to move the 20 over. Let's see what we have. We have 8 plus 4 is 12p. These are gone. And then we have 80 plus 20 is 100, and these are gone. Now we'll divide both sides by 12 to figure out our price. And again, with our calculator, 100 divided by 12 gives us $8.33. All right, so now we know our price. We know that P is $8.33, which sounds good. In order to figure out the quantity, we just need to plug that in for P somewhere. So let's go ahead and use the demand function, and it doesn't matter which function we use, but we'll go ahead and use the quantity demanded. Is going to be equal to 80 minus 4 times $8.33. So again, let's take that times 4, and we're going to subtract that from 80. So 80 minus 33.33 is 46.67. So the quantity demanded is 46.67. So this point right here is 46.67, our quantity demanded for a price of $8.33. Great. Now we have learned how to solve a system of equations, basically, and finding the equilibrium. And now finally we are going to try one more problem that is not linear. In this set of problems, our quantity demanded is quadratic, and our quantity supplied is linear. So let's do what we just did. Let's go ahead and set them equal to each other. Let's try this algebraically, and then I'm going to show it to you graphically. Okay, when we set these equal to each other, what we have here is negative x squared minus 2x plus 100 equals 8x plus 25. What I'm going to do though is go ahead and move over the x squared to the other side so that it's positive, so it's easier for me to factor this. And I'm going to move, in fact, everything over to the other side. So I'm going to add x squared, I'm going to add 2x, and I'm going to subtract 100 all to this side. So I added 2x here, I subtracted 100 here, and then I added x squared. So this side becomes 0, and this side, I'm going to go ahead and write these in order, equals x squared plus 10x minus 75. Okay, this is our quadratic, so let's see if we can do some quadratic factoring. Now I'm going to take a shortcut this time because I don't have anything other than a 1 right here. So the way I do that is I make my two factors. I put x here and x here because x squared breaks into x and x. And then I have to ask myself, what times what is 75? That adds to be 10. So we can start thinking of some things like 25 times 3. That wouldn't work because 25 and 3 won't get us 10. What else makes 75? How about 15 times 5? That would get us 10. So we want a positive 10, so we want the 15 to be positive, and we want the 5 to be negative. Now notice that this shortcut only works if there's a 1 here. Let's go ahead and solve. So in this first one, if we set this equal to 0, we get negative 15. And on this one, we get positive 5. So the answer would be 5 because remember, negatives aren't going to help us. So x will represent our price. In order to figure out the quantity demanded, we just need to plug it into one of these. And I think this one would probably be a lot easier. So let's plug it into 8x plus 25. So 8 times 5 plus 25 will get us our quantity supplied. So that's 40 plus 25 is 65. All right, so now we have our answer. So for a price of $5, we can supply 65. That is our equilibrium point. Let's go ahead and look at this function graphically. Here's our two functions that we have graphed. Here's our quadratic, and here's our linear. If we look back, our quadratic was our demand curve, and our linear was our supply curve. Now in these equations, x is representative of our price. So when we graph it mathematically, price is down here on the x-axis. So we just have to be careful we interpret this correctly. Even though economists will often put, like I said, the price here on the vertical axis, when we do it graphically, mathematically, x is always going to be down here. So for a price of $5, we're willing to supply 65, and people are willing to buy 65. That is our equilibrium point. And that concludes our lesson on supply and demand, putting it all together. Hopefully at this point you understand that relationship between supply and demand, as well as be able to calculate the equilibrium point both graphically and algebraically.